In today's lesson, we're going to talk about properties of quadratic functions, and we're going to get through a lot of information today, so I'll try to go as quickly as possible. Let's start with the basics. First, a quadratic function is a function that can be written in the form f of x equals a times x minus h squared plus k, and that's vertex form of a quadratic, and we'll get to that later. So let's first review the parent quadratic function, which is our most basic quadratic function. That looks like this: f of x equals x squared. You can also write that as y equals x squared. Remember, f of x is just fancy smancy for y. So y equals x squared, f of x equals x squared. I can create a table of values by plugging in these points that I've written here in for x, and I get an output of these values for y. Now, why do I get that? If you notice, let's look at this. When x is -4 and when x is 4, my y values are the same. Why is that? If I have -4 squared, I get a value of 16. If I square 4, I also get a value of positive 16. So if I square a positive or negative value, my answer will always be positive. So as you can see, the y values for this quadratic function are restricted to anything above the x-axis, right? Because if I square a positive or negative, I get an output of a positive value. So first, let's talk about graphs of quadratics. Form shapes called, and I'm going to highlight this because it's a really important vocabulary word, parabolas. So that's the shape of a quadratic. Let's move on and let's talk about properties of parabolas. I'm going to go through each one of these bullet points. So for the quadratic equation, y equals ax squared plus bx plus c, you may recall this from Algebra 1, where a, b, and c are real numbers. A cannot be 0, right? I'm going to have an x squared term in my equation. The parabola has these properties. So first, if that a value is greater than 0, meaning it's positive, your parabola is going to open up. So let's draw this, and the parabola opens down if a is less than 0. So if a is a negative value, your parabola opens up. If a is a positive value, your parabola opens down. So I'm actually going to draw, let's see, right here, you can see on this first one right here, a must be greater than 0 because my parabola opens up. For this one right here, a must be less than 0 because my parabola opens down, right? Those arrows are pointing down. Let's move on to the next bullet point. If the parabola opens up, the vertex is called a maximum. If the parabola opens down, the vertex is called a minimum. So this vertex right here, which is your highest or lowest point of your quadratic, that vertex is called a minimum. Right here, this vertex is called a maximum. So both of these can be identified as a vertex, but we can just be more specific by calling them a minimum or a maximum. And then lastly, another property of a parabola is the axis of symmetry is an invisible vertical line through the vertex of the parabola. It splits that parabola in half. So I can draw a vertical line right like this, and I'll call it my axis of symmetry. It is invisible. We can't see it. It's just a property of a parabola, and I can shorthand it AOS. Right here, goes through that vertex. It's a vertical line. I can have an equation for it. We call that our axis of symmetry. So these are some properties of parabolas. Let's move on to the next topic, quadratic equations. There's a lot of information right here, and I'm going to go through each one of these. So first, let's talk about the different forms of a quadratic equation that I can write. So we can write quadratic equations in 3 different forms. The first form is standard form. Y equals ax squared plus bx plus c. And here are some benefits of this standard form. These are just meant to be like bullet points for each form, and we'll talk about each of these forms over the next several lessons, but this is something that you can refer to when you're like, no, what is this form? Okay, yeah, right here. So the benefits of this form are that the end behavior is easily identifiable. So the degree of the polynomial is 2, the function is even, f of x approaches the same on both ends. So what does that mean? That means it will open up, right? So both arrows open up, or it'll open down. So both arrows end down. That's how you can think about that. The other benefit is that the value of a is easily identifiable. It's also known as your leading coefficient. That tells us if the parabola opens up or down. So right here, your a value, that tells me, does it open up? Does it open down? Do I have a minimum or do I have a maximum? Now let's get to your formula for your axis of symmetry. That axis of symmetry is an invisible vertical line. I can actually calculate the equation for that axis of symmetry. Now, because it's a vertical line, the equation is going to be x equals. X equals what? Your formula is negative b over 2a. Because that axis of symmetry goes through the vertex, right? So if I have a parabola that looks like this, my vertex is right there. That axis of symmetry goes through that vertex. X equals whatever that is, that number, x equals whatever number that is, that's going to be the x value for your vertex. So here's your formula for your vertex. The x value, and because it's a point on your coordinate plane, we're going to have an x and y coordinates. So the x value is going to be negative b over 2a. The y value is going to be f of negative b over 2a. Now what the heck does that mean? That means I'm going to take that x value, plug it into my equation up here, and whatever I get for the y value is the y value for your vertex. Let's move on to the next equation, vertex form. So what is a vertex, right? The vertex is the highest or lowest point of your quadratic. Here's the formula for your vertex. Y equals a times x minus h squared plus k. Benefits include your axis of symmetry. Your axis of symmetry is x equals h. Be careful here, and we'll practice this more later. X equals h. That's that point right there, or that's that, whatever that number is, right there. X equals h. Your vertex is hk. Right there and right there. So you can easily see your vertex. But what I want you to do is be very careful, because let's say you have something like this. Y equals 3 times x plus 4 squared plus 1. So my question is, what is the value of h? And I'm going to change colors here. What is the value of h? Well, let's rewrite this. We've got y equals 3 times x minus h must be negative 4. You know what? I'm actually going to write that in a different color so you can see that negative 4. Why would h be negative 4? Because when I've got like y equals 3 times x plus 4, well, my equation is y equals a times x minus h. So if I rewrite my equation like this, where I have x minus, what would h have to be so that when I simplify it, I get x plus 4? It must be negative 4. So your axis of symmetry here is actually x equals negative 4. And then if I take that negative 4 and I plug it into, I'm sorry, I don't need to do that for this one. My vertex is actually hk, which would be h is negative 4, k is positive 1. So it would be negative 4, 1. So you can easily identify your axis of symmetry and your vertex. And then the very last form, sorry, I'm trying to go kind of fast, but I'm not really going fast, is intercept form. This is factored form, y equals a times x minus p times x minus q. Your benefits include that the x-intercepts of the quadratic are easily identifiable, and we'll get to this as well. Not in this particular lesson, but we'll get more to this. These are also called solutions, roots, and zeros. But a big thing that we're getting into in Algebra 2 that you don't necessarily talk about in Algebra 1 is not all quadratics have real roots. Some have imaginary roots. So intercept form is not always applicable. So let's move on to the next thing. The next thing says, find the axis of symmetry and vertex for each quadratic function in standard form or vertex form. Draw a sketch and determine if the vertex is a minimum or a maximum. So I've got this equation right here, or function, right? It's in function notation, function form, because it's f of x equals, right? If I saw y equals, it'd be the same thing, right? But it would be called an equation. So f of x equals x squared plus 2x minus 5. Let's first identify what a, b, and c are. Those are just the coefficients of each term. So if nothing is in front of that x squared, a is 1, right? B is 2, c is negative 5. I've identified a, b, and c, and if I refer to my notes up top, the formula for the axis of symmetry is x equals negative b over 2a. So what I'm going to do for my axis of symmetry is I'm going to plug in negative b, which is negative 2, over 2 times a, which is 2 times 1. And then I'm just going to simplify it. That's negative 2 over 2, which is negative 1. My axis of symmetry is x equals negative 1. So I'm going to draw a vertical line at x equals negative 1, right? All right, and I'm going to label it. And now we're going to move on to the next thing, and I'm going to change colors here. Let's do this one. So now let's find the y value of the vertex. So the y value of the vertex is, I'm going to plug in negative 1 for x on my equation. So I'm going to say y equals, and what I'm going to do first is I'm going to put parentheses everywhere I see an x, okay? And then I'm going to plug in that x value into those parentheses. So it's going to be x squared plus 2 times x minus 5. And then in those parentheses, I'm going to put a negative 1. And then let's simplify this. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 5. 1 minus 2 is negative 1. Negative 1 minus 5 is negative 6. So my vertex is negative 1, negative 6. And I'm going to go down here. I'm going to put that point right there. And I'm going to label it negative 1, negative 6. And then the very next thing that we're going to do, the last thing we're going to do for this, is we're going to determine, is a positive or is it negative? My a value is positive, which means my vertex is a minimum, because a is greater than 0, which means your function is going to look like this. And we're just going to draw a general sketch, right? We're just kind of like getting to know or reviewing quadratic functions here. So let's move on to the next couple of examples. And I'll try to go quickly through these, as quickly as I possibly can. So on number 2, I've got standard form of a quadratic, where a equals 4, b equals negative 16, and c equals 6. So the first thing I'm going to do is just identify my a, b, and c values. And then I'm going to look for, or calculate that axis of symmetry, which is x equals negative b over 2a. This is a formula you usually are given for any test that you're doing, or it's on your formula chart. X equals negative b over 2a, axis of symmetry. You just have to know what the heck it is, right? You're using that formula to determine your axis of symmetry, so you really have to know your vocabulary here. So your axis of symmetry here is going to be x equals, and we're looking for our axis of symmetry, negative b, which is positive 16, right? Negative, negative 16, so negative b, negative, negative 16. Some people say opposite b, same thing, right? Opposite b, because negative, negative, that makes positive 16. So negative b over 2 times 4. That's 16 over 8, which is 2. So my axis of symmetry is x equals positive 2. So I'm going to draw that first. Here's x equals 2. And now let's move on to our vertex. So our vertex is going to be, I'm going to plug in, everywhere I see an x value, I'm going to plug in this 2 right here and determine what is the y value when x is 2. So I can actually write it like this. What is f of 2, right? This is my vertex. I already know that the x value of my vertex is 2. What's the y value? Well, let's find f of 2. That's going to be 4 times 2 squared minus 16 times 2 plus 6. And we'll just simplify this a little bit at a time. 2 squared is 4. 4 times 4 is 16. Minus 16 times 2 is 32 plus 6. So what do we have here? 16 minus 32 is negative 16. Negative 16 plus 6 is negative 10. So f of 2 equals negative 10, which means my vertex has a y value of 10. So if we graph that vertex, did I do that right? It's actually negative 10. There we go. So my vertex is going to be like down here, right? So 2, negative 10. That's my vertex. And then let's determine if it opens up or down. I have an a value that's positive, right? That's a positive 4, which means a is greater than 0, which means this parabola opens up and that vertex is a minimum value. Let's move on to number 3. So now we've got a function, a quadratic function, that's in vertex form. And this is a little easier. There's not like so much calculating we have to do. Let's first find the axis of symmetry, right? That's x equals, because it's a vertical line, what is the value of x? I'm sorry, of h, right? X equals h. This right here, just remember that that's x minus negative 3 squared, which means h is negative 3, right? So shortcut, how do we think about this? If it's x plus 3, your h value is going to be negative 3. So x equals negative 3. And I'm going to graph that vertical line right here. X equals negative 3. Now let's move on to the vertex. I'm going to do this in a different color. The vertex, remember, is hk. K is negative 4. H is negative 3. My vertex is negative 3, negative 4. And let's plot that. Negative 3, negative 4 is about right there. I've got that vertex. Remember, that's your highest or lowest point of your quadratic. And now let's move on to determine, is this parabola going to open up or is it going to open down? You have an a value right here that's less than 0. That's negative. It's a negative 2. Your a value is less than 0, so is it going to open up or is it going to open down? My parabola is going to open down, which means that vertex is a maximum. Let's move on to the very last one. So in this problem, it's in vertex form, and we have f of x equals 3 times x minus 1 squared plus 3. So what's the value of h? Remember, this is x minus, what's the value of h? 1 squared. X minus 1. It affects it by x minus h, which means h is positive 1, right? So there's that little trick. If you see x minus 1 inside your parentheses, that means your h value is positive, which means your axis of symmetry is x equals positive 1. So let's draw that. X equals 1. Let's move on to the vertex. So what do I need to do to find the vertex? I already have my h value, which is 1. And remember, that vertex, it's hk, right? So where's k? K is right here, which is positive 3. My vertex is positive 3. That's 1, 3. And that's right there. And I can label it 1, 3. And now let's determine, we're just drawing a general sketch, right? We don't have to be perfect. Is it going to open up or is it going to open down? I have an a value over here that's positive. which means it's greater than 0. So it's going to open up, and that vertex is a minimum or maximum? Minimum. Okay, let's move on to the very, very last thing that we're going to do in today's notes, and that is we're going to draw a graph that has all of the points for this quadratic on it. It's very detailed, and I'm going to show you how to do this. You can do this with any function, but let's get into how to really do this with quadratic functions, okay? Because a lot of students are like, where do I start? Start with your axis of symmetry, okay? In this particular function, it's in standard form. F of x equals negative 2 x squared minus 8x plus 1. Let's start with our axis of symmetry. So let's label. A is negative 2, B is negative 8, C is 1. Remember, your axis of symmetry is negative b over 2a. So this particular one is x equals negative b. Well, b is negative 8, so negative b or opposite b is going to be positive 8 over 2a. That means 2 times negative 2, which is 8 over negative 4, which is x equals, what is 8 divided by negative 4? I can simplify it to negative 2. My axis of symmetry is x equals negative 2. So what I'm going to do is I'm going to go ahead and plot that axis of symmetry on my coordinate grid. There's x equals negative 2. And now let's find the vertex. So we're doing the exact same things that we did in the previous 4 problems, but we're graphing it a little more specifically. Okay, so let's move on to the vertex. How do I determine the vertex? Well, I'm going to plug in this negative 2, right, in for x everywhere I see x in my function. So I'm finding f of negative 2, right? So I'm going to plug it in. Negative 2 times x squared. What is x? X is negative 2. Minus 8 times negative 2 plus 1. And then I'm just going to simplify it a little bit at a time. So let's see, negative 2 squared, negative 2 times negative 2, right? That's positive 4. 4 times negative 2 is negative 8. I'm just simplifying this using my order of operations. Negative 8 times negative 2 is positive 16, so that's how I write it. Positive 16 plus 1. Negative 8 plus 16 is positive 8. 8 plus 1 is 9. So f of negative 2 equals positive 9. My vertex is negative 2, and then we got a y value of positive 9. Negative 2, 9. There's my vertex right up there, okay? Negative 2, 9. Now, in this case, in this example, I'm going to make a table of values, find other points, and plot them on this coordinate grid. I have a little arrow right here that tells you to put your vertex right here. If that's the highest or lowest point on the graph, I want to see what is the graph doing to the left and to the right of that vertex, right? So what are the x values that are to the left? Let's change. Let's do this right here. What are the x values that are to the left? Negative 3, negative 4, negative 5. What about to the right? Negative 1, 0, and 1. So now we're going to determine the y values for each of these x values. I want you to pause the video and do that now. Now we're going to plot these points on our coordinate plane. The first thing I'm going to do is I'm going to look at, let's see, I'm going to change colors here, right here, and I'm going to start with x equals negative 3. When x equals negative 3, y is 7, which is right there. And then I'm going to plot the point that's to the right of my vertex, which is when x equals negative 1. Y is also 7. Then I'm going to plot the point that is 2 to the left of my vertex, which is when x is negative 4, y is 1. That's right there. And then I'm going to plot the point that's to the right 2 units from that vertex, which is when x is 0, y is 1. Notice that our y values are the same right there. Now let's go 3 units to the right of my vertex, which is when x is -5, y is -9. When x is 1, y is -9. Do you see what's happening here? Whoop! And I can't really do this very well on this one. It kind of looks like a V, but what I want to show you is that axis of symmetry. Notice right here, that's 1 unit away from your axis of symmetry, that's 1 unit away. This is 2 units away, this is 2 units away, right? This is 3 units away, this one is a mirror image, and that's 3 units away. Your vertex, because your A value is negative, your vertex is a minimum or a maximum? It's a maximum value. Whew, this was a long set of notes, but I hope it was helpful. I hope it served as a really great review for your properties of quadratic functions.